Ladies and gentlemen, welcome to section 12.7, Probability of Compound Events, Part 2. Now here, ladies and gentlemen, let's start off with a vocab word, mutually exclusive events. That means there are no common outcomes. So if we look at the probability for it, like in the previous video, we have probability of A, now plus, ladies and gentlemen. Big key here, this is a plus the probability of event B with no common outcomes. If we look at the Venn diagram, here's event A, here is event B. They share no common outcomes. Big key here with mutually exclusive event. We are just looking for one item. That is just one item. We are picking one thing. That's the key with mutually exclusive or overlapping events that we'll get to. So here's some examples of a mutually exclusive event. A die is being rolled. That's a singular for a dice. So there are 6 numbers on a dice or a die. Find each probability. So the probability of being a 3 or a probability of being a 5. So how do we write that down? It's going to be the probability of a 3 plus the probability of a 5. There is only 1 3 on a dice out of a total of 6. Our total is 6. And then it's going to be plus how many 5s are on a dice. There's only 1 5 on a dice out of a total of 6. So we add those together. So it's going to be 2 over 6. Or if we simplify to be 1/3 for our final answer. And please just keep it as a fraction. If you wanted to write it, or if you want to write it as a percent, it would just be 33.3%. Now, how about less than a 3? Ladies and gentlemen, what numbers are less than a 3? That's going to be a 1 and a 2. It doesn't say less than or equal to 3. It's just less than 3. So we're looking for the probability of being a 1 or the probability of being a 2. How many 1s are on a dice? There are only 1 out of a total of 6. Plus, how many 2s are there on a dice? There's only 1. There's only 1 over a total of 6. You add those up. That's 2 6 again. You can simplify it to be 1/3 for our answer. Now with number 3, the probability of being even. What even numbers are on a dice? We have 2, we have a 4, and we have a 6. So we have the probability of a 2 plus the probability of a 4 plus the probability of a 6 written algebraically. Probability of a 2, we have 1 2 on a dice over a total of 6 numbers. We have 1 4 on a dice out of a total of 6 numbers, and then we have 1 6 on a dice out of a total of 6 numbers. You add them up because they are mutually exclusive events, so it's 3 over 6. We simplify that. Please simplify your fractions to get 1/2 or 50%. Next vocab word is overlapping events. Overlapping events have at least one common outcome. And we write this algebraically, the probability of A plus the probability of B, but we take out what they have in common. So if we look at event A, we would take the probability of event A plus the probability of event B, but now see how they have these 5 and 3 in common? We would subtract out the probability of a 5 and 3. So that's what this minus probability of A and B. So let's take a look at it here real quick. If I can get it to show up for us. Here we have a survey. Out of 5,200 households surveyed, we have 2,107 had a dog, 807 had a cat, and 303 had both a dog and a cat. What is the probability that a randomly selected household has a dog or has a cat? So we're going to write this algebraically like the probability of a dog, and then it's going to be plus the probability of owning a cat. But now what do we have to take out? We have a dog and a cat. What did we count both? Well, we counted this twice, right? Because we counted a dog and a cat. So we have to take that out because we counted those dogs here and those cats here. So we have to take this 303 out. So it's going to be minus the probability of a dog and cat. So again, what's our total? Our total is 5,200. How many of those have a dog? That is 2,107. This is a 7. Plus probability of a cat. We have 800. 7 own a cat out of 5,200. Minus now, how many own a cat and a dog? We have 303 out of 5,200. So you punch into your calculator, you come up with roughly 0.50, or as a percent, move the decimal to the right to change it to a percent, so it's 50% for our answer. Let's try one more. Here in the game of bingo, we have balls or tiles are numbered 1 through 75. These numbers correspond to a column on the bingo card as shown in the table. So here are the numbers in each column. A number is selected at random. What is the probability that it is a multiple of 5? So we're looking at multiples of 5, or in the end column. So let's first see if we can write this algebraically. We are looking for a probability of a 5 plus the probability of an n. But did we count anything twice? Yes, we did. We counted the multiples of 5 and n's in this column, so we have to take those out. So it's going to be the probability of a 5 and an n. So first things first, we have to find how many 5s are in each column. So multiples of 5. What are the multiples of 5 in here? Well, we have a 5, we have a 10, and we have a 15. So we have 3 multiples here. What about this guy? We have 20 is a multiple of 5, 25, and 30 is also a multiple of 5, so we have 3. Is that the same for each column? Yes, it is. We have 3 multiples here, 3 multiples here, 3 multiples there. So the total number of 5s, I'm going to say total 5s equals 3 plus 3 plus 3 plus 3 is 15. So we have a probability of 15 out of, what's our total? Our total is 75, so it's 15 over 75 plus. Now how many are in n? We have 15 numbers in n, so it's going to be plus 15 over 75. Now we have to take out the 5s that are in the n column. So how many 5s are in the n column? Well, we have 3 right here, so we have to take out 3 over a total of 75. Subtract those out. So we add them up, subtract them out, punch into your calculator. You get 9 over 25 for your simplified fraction. You could also make this a decimal, or you could also make this a percent. I'm going to leave it as a fraction. But, ladies and gentlemen, that does it for section 12.7, Probability of Compound Events, Part 2. Good day.